Okay, if you've taken statistics, you've probably seen this before. And 12 and 9 up here. Um, it's asking for a combination. This is like shorthand for saying 12 factorial. And don't worry if you haven't seen an exclamation point. I'll explain in just a second. And then 9 factorial on bottom. And then it's 12 minus 9 factorial. Okay, so a couple of things there. The format is n over r. In this, with the n above the r, that means you do n factorial over r factorial n minus r factorial. And all a factorial is that if you have like 5 factorial, it means you multiply every number as you descend to 1. Oh. Sorry, computer's having a hard time. 5 times 4 times 3 times 2 times 1. Okay, that's 5 factorial. Okay, so to simplify this, there's a shortcut. Instead of trying to do 12 times 11 times 10 times 9, you can just do 12 times 11 times 10 and then stop there, because look, whatever 9 factorial is, it's going to cancel out with whatever 9 factorial is on bottom. So you got something much simpler to calculate. You just got to do 12 times 11 times 10 over 3 times 2 times 1 if you want to be thorough there. Okay, so 3 times 2 times 1, that means we got 6 in the denominator. We got 1,320 in the numerator. That's 220. All right, let's try something else. So what do we got? Find the coefficient of x squared y to the 6 in this expansion. Give the so what we have to help us with this problem is the binomial expansion theorem. Okay, or the binomial theorem. What it does is it helps us imagine what terms are going to look like when you try to expand. You know, if you remember doing this before, you would evaluate it by doing 2x plus 1 times 2x plus 1. You multiply it to itself, right? So you're going to get something squared for the highest power of x. If you do 2x plus 1 to the third, now your calculation is getting pretty intense, because you're going to get 2x plus 1 times 2x plus 1 first, find out what that is, and then put it in a parentheses and multiply it to another 2x plus 1. So instead of trying to do all this arithmetic out, we have this the binomial theorem that's going to help us figure out what the terms are in the sequence. You would add all these terms up from k equals 0, and look at k. K is just the power on top of x. When the power of x is 0, the power of x is 1, the power of x is 2, the power of x is 3, all the way to some power n. Okay, this multiplies, this expands out by adding each of these terms to one another. Okay, so maybe just one quick example. Let's say 3x plus 2y to the second power. Using the binomial expansion theorem, we're supposed to do n is 2 and k is 0. Start at k equals 0. And then we got 3x to the k power. We said k starts at 0. And then we got by to the n minus k. So 2 minus 0 makes 2. Now this symbol here means plus. Okay, so you're supposed to, it means summation, sorry, it means add them all up. We're doing plus, but several times, okay? So we start at k equals 0. Now we're supposed to move up to k equals 1, then keep going until you reach n, okay? Go from 0 to 1 to 2 to 3 to 4 until you reach whatever your n is. So we did k equals 0, now we're doing k equals 1, so we got 3x to the first power times by. Now look, this is going to be 2 minus 1. That makes 1 here. And then we got 2 over 2 on top of 2. 3x to the second. And then we got by to the 0. And then once you simplify these, you know, you can find this with the combination formula we just did. Once you simplify these, then you have the full expansion without actually having to go through and do that multiplying. Okay, it would probably be easier when k equals 2. I just used a small number, but you know, you can see how this formula could be useful if you have like k equals 500 or something, right? That way you don't want to multiply all those parentheses. Okay, so that's kind of a long-winded introduction into a short problem that we have here. We have 2x plus y to the 8th. We're supposed to find out the coefficient, which means the number in front, okay, when x has a power of 2 on top. In other words, we're supposed to figure out what this thing looks like when we're supposed to find out the term. You know, we got a bunch of terms adding to each other. You got x to the first, y to the seventh, plus x to the second, y to the sixth, plus x to the third, y to the fifth, etc., etc. We're supposed to find out what's going on here, what the coefficient is for this term. In other words, we want to know when k equals 2, what does it look like? Okay, so n is fixed. N is the power of the thing you're trying to expand. So n is 8. K is 2 because that's the power on top of that first variable, on top of that x variable. And so careful with your a. You have 2x to the second power. And then we got b is 1, right? Because there's no number in front of our y there. We got 1y to the 8 minus 2 power. That's what that term is going to look like. You know, we would normally add this if we were trying to expand that binomial. But we're just asked for what the coefficient is out front. Okay, so let's do some simplifying. 8 with a combination of 2, so that's 8 times 7. The 6's will cross cancel, and then we need to divide that by 2. 8 combination 2 is 28. Okay, this right here is 28. And now look, 2 squared makes 4, so I'm going to expand that because I did 2, it's being squared. And then we got 8 minus 2 makes a power of 6 on the y. So 28 times 4, we got 112 x to the second, y to the sixth. So that's our coefficient. Looks pretty weird probably the first time you see it. So let me see if I can find another example. Now this one just says give the whole expansion, so we'll get to use that formula again. That last question just asked for one term. This question asks for the full expansion. So we're going to add all the terms from k equals 0 to k equals 3, okay, to the highest power. So let's start with the first one. We've got n is 3, k is 0, and then we've got a is negative 1, x, it's not going to matter for this first term because it's all being raised to the 0 power. Then you multiply that to bz, and this is to the third, right? Because it's n minus 0. Yeah, it's n minus k. 3 minus 0 makes 3. That's the first term. Then keep going up. Make k go to 1. So we got negative 1x to the first power because k equals 1. Then you got 4z to the second power plus 3 to, you've got negative 1x to the second power, 4z to the first power, and then finally k is finally equal to 3. That's where this is our last term. 3 over 3. Oops, not over 3, on top of 3. Negative 1x to the third, 4z to the 0 power. Okay, so 3 combination 0. That means you got 3 factorial over 0 factorial, which is 1 by definition. Okay, I got 3 minus 0 factorial here. This is just going to equal 1. So this thing out front is equal to 1. And then negative 1x to the 0 power. Anything raised to the 0 power is 1. And then we have 4z to the third. So that's 4 to the third is 64. Z to the third is just z to the third. So that's our first term. Okay. Our second term, I could probably expand this. We don't need that other side. 3 combination 1. Let's see. That's going to be 3. 3 times 2 is 6. I got to do it out. I can't do it in my head here. 3 factorial over 1 factorial. 3 minus 1 factorial. So that's 3 times 2 factorial over 2 factorial. So 3 over 1. 3 combination 1 gives us 3. And then we got negative 1x to the first power. You got 4z squared, so that's going to be 16z squared. That's the second term. Third term is going to be 3 over 2, so I think that's also going to be 3, right? 3 times 2 factorial. Yep. 3 combination 2 is also 3. Then we got negative 1 squared. Watch out for that. If you square negative 1, it makes positive 1. Right? And then over here we got 4z to the first. And then finally 3 combination 3, that just makes 1, okay? So that's 1. It's got negative 1 x to the third. Negative 1 to the third power is going to be negative 1. Sorry. Don't know why that shrunk. And then we got x to the third, and then this whole term is going to be 1. Right, because anything to the 0 power is 1. So we finally got it. Just a little more simplification to go, but we're basically just adding these 4 terms up, because that's what this summation symbol says up here. It says add up each of the 4 terms. So my first term was 64z to the third. Hopefully the order doesn't matter with our variables. We've got now 3 times negative 1 makes negative 3. Negative 3 times 16, negative 48. So we're going to change that to subtract 48z, so 48xz squared. Okay, and then we got 3 times 4 makes 12 for that third term. X squared z. Careful, make sure your z doesn't get stuck in that exponent. And then negative 1x, so it's, yeah, negative 1x to the third for that final term. Okay, that's it. So binomial expansion definitely looks weird the first time you do it, but try playing with those numbers, you know. In this one, n equals 3. So the first term should be 3, 0. Negative 2x to the 0. Negative 4y to the 3 minus 0 makes 3 up here. That's the first term of the expansion. Okay. And then it's 3 over 1. Negative 2x to the 1 power. Negative 4y to the 3 minus 1 makes 2. Negative 4y to the second power for that next term. And you just keep going in that fashion.